Morning, peeps. This was last class, so was that. This is today, the Doppler effect. I think when I was a kid, that may have been when they invented or discovered the Doppler effect. Lots of times, lots of news radio stations, weather stations were talking about Doppler radar, Doppler, and it was like big fancy lettering and stuff. Because I'm getting old, I guess. That's the lesson here today. Anyways, Doppler effect. While you weren't listening to me and you were writing down the notes, we both got things done. Okay. When a sound approaches an observer, it says, this is assuming that the observer, for our purposes, we're assuming the observer is not moving. Okay? That's why it's asterisk. You're going to get the formula on the next page. When a sound approaches an observer, the sound waves are compressed. I don't know how well you can see that. What page is that in the textbook? That is obviously page 433. Page 433. When they approach, the sound waves are compressed. As they leave, the sound waves are spread out. So that's what it says here. The sound waves are compressed and the frequency is higher than if the source of the sound is static. As the source of the sound recedes from an observer, so as it's moving away from you as opposed to approaching, the frequency detected is less than the true frequency of the source. This is called the Doppler effect. Oh, I asterisked that because provided the sound of or the velocity of the source is reasonable. But it's also true that the observer is motionless for our purposes. When it's coming towards you, it's higher. When it's moving away from you, it's lower. And that is shown mathematically right there. I'll let you take it down, and then we'll talk about it. Excuse me. So that's the formula. F obs is the observed frequency. It sounds like F naught is the true frequency. That's what it is. But it sounds different when it's on something that's moving pretty fast. It's on a car flying past you. You notice how it sounds high as it's coming, and then it's lower as it goes. On top, the speed of sound plus the speed of whoever's detecting it. For our purposes, 0. On the bottom, speed of sound. So these two numbers will be the same, but the bottom is this plus the speed of the source. How fast is that source going? Everything should be in meters per second. But here's the one little trick about that plus sign. When the source is moving toward the detector, that's negative. Okay, so make a note as you need. That is negative. When the source is moving towards the detector, that's negative. When moving away, it's positive. We're going to do the practice. It's 2 questions, page 435. Then you got that, and then that's that for this unit. I'll put out the assignment expectations on Thursday. Probably tomorrow I'll put out the rubric. And then no class Friday, no class Monday. Good grief. The schools in Quebec, some schools in rural areas opened yesterday. Isn't that crazy? I think the rest of Quebec is supposed to open May 25th for school. Wouldn't it be weird, like, I think the chances of this happening are 0.00001. Wouldn't it be weird if we open like June 7th? Come back for exams or something like that. I'm laughing because of the ridiculousness. I do not think that's going to happen. All right. This way. And I think I pulled markers out. They're there. All right. So let us begin. Practice page 435. Practice. Page 435. 1. Where is it? It says a police car is approaching at a speed of 20. So the police car is approaching. Okay? So first of all, this is V source, because that's where the sound's coming from. And it's approaching, so it's negative. and it's approaching at a speed of 20 meters per second. And then the question says its siren is emitting a frequency of 1 kilohertz or 1,000 hertz. So this is not what the observer is picking up. This is what the siren is doing. Okay, so this is the F naught, and it is what? 1,000 hertz. What else? It says what frequency does a stationary observer detect? So F obs. That's what we want to solve for. Oops, equals a question mark. And the speed of sound in this case is 330. V sound equals 330. Here's a question. Why did I do this right in the middle of the page? I didn't really give myself a whole lot of space here, did I? Hate wasting space. Okay, I'm going to write out the formula, if I can fit it. F naught, this is V sound, plus V source. Okay, it's not super clear, but I know you guys have the notes handy that you just wrote down. So this is what we're solving for. What does the observer pick up? What do they notice? What do they record? So that's what we're trying to solve for. Speed of sound, we're told, is 330. The detector, is that us? Who is it? Is it a human being? A stationary observer. Stationary. They're not moving. They never will. We're not doing questions where anybody's moving. V sound again. This time we're adding or subtracting the source. I shouldn't have wrote the plus sign so quick. Minus 20. Minus because it's approaching. If it was receding, it would be plus 20. Times F naught, which is 1,000. So essentially what this is 1,000 times 330 divided by 310. Okay? So it's 330 divided by 310, right? Because 330 minus 20 times 1,000. You could have done 330 times 1,000 first. That's fine. So how many sig figs in this question? 2. 2 sig figs. So that's 1,100 hertzes. It's not hertzes, don't say it that way, it's just hertz. Cool? That's first practice. Relatively straightforward with this formula. You just got to remember the positive and negative. You got to read the question carefully to see is this coming or is this going? Sometimes they word it a little bit trickle-a. Numero dos. I wrote that really small. An ambulance has just passed. Okay, so it's moving away from you. You detect that the frequency, this is what you're detecting, okay, that the frequency of the receding siren is 900. So F obs is 900. This is what you are observing. This is what you detected. That's what it says. If you know that the frequency of the ambulance siren, the frequency is actually 950 because you're an ambulance driver. This is just your day off. If you know the frequency of the ambulance siren is this, how fast is the ambulance moving? So V source, that's what we're trying to figure out. How fast is it moving? Speed of sound is 335. Notice that it keeps giving us the speed of sound. You may get a question. I don't remember, to be perfectly honest. You may get a question that says it's 33 degrees outside, and that's all it says about the speed of sound. So you got to figure it out with that equation 331.4 plus 0.606 times time. Then you have to figure out the speed of sound then dependent on the temperature. Okay, so a formula, F obs equals V sound plus 0, because that's what the detector always is. V sound. It's too bad they're both S's, because you can't do S, can't even do SO. Can't even do SOU. They clearly didn't think this out. Okay, what do we know? We know that we're observing 900. Speed of sound, we're told, is 335. plus 0. I'm going to write that down. 335 plus, oh, we don't know how fast this bad boy is going, so that's the x. F naught is 950. So, we, a few different ways we can do this. What I would be tempted to do, and it's what I will do, I think, is I'm going to multiply this 950 through instead of dividing it. You can do either one. Either one's easier. You know what? It might be better habit if we divide both sides by 950. Just move towards getting that x isolated. So 900 divided by 950. 0.9474. 0.9474 equals 335 over 335 plus x. You cannot cancel these 335s. You cannot. This is a whole term. This is a whole term. So we just switch these two. The magic triangle, right? If we multiply both sides by 335 plus x and then divide both sides by 0.9474, it'll switch these two. So 335 plus x equals 335 over 0.9474. So 335 divided by 0.9474, 353.599. That's what 335 plus x equals. So we subtract 335 from both sides. Minus 335 equals 18.59. How many sig figs? 18.59. In the question, everything's 3 or 4 sig figs. So it's going to be 3. So this equals 18.6 meters per second. Is that what the answer says? Yep. Cool, cool, cool. Cool, 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 cool. 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 All right. Peace, love, and egg rolls. See you later.